All right, welcome to today's course. So we will be talking about how we are using DOSDP templates within ODK workflows. This is a kind of intermediate level tutorial. So for this tutorial, we expect at least that you have some kind of vague idea of what a DOSDP template is. If you don't have any idea whatsoever, you might still get something out of this because we will brush on at least some of the concepts throughout necessarily, but in order to really get the most out of this tutorial, you should understand a bit what are DOSDP templates and also have an idea from one of our past ODK courses, what exactly is the ontology, or what is the ontology development kit. So this is the page here. I don't know whether, Nicole, you want to share this around. I would just want to note here in the book, there's a new section. So in the template section, you see like a bunch of subsections now. One of them is Introduction to Managing DOSDP Templates in ODK. And this is along with this basic tutorial, which you've already done. Or at least looked at, and then an overview of DOSDP templates that we are currently working on. So it's a bit of a construction site, but this here is at least for now a good feature complete intro in how to use DOSDP templates from within the ODK. All right, so before we start, I want to emphasize a few concepts, like what they mean. You have all kind of been taught by us, that's kind of our fault, so mainly David and mine, some kind of like terminology around DOSDP, which is slightly inaccurate. For the sake of this tutorial, we want to just make sure that we all get the terminology right around DOSDP. So in particular, the words template, template string, pattern, and DOSDP template table. So the template, so when we talk about the template, a template generally is some kind of a document, some kind of artifact that contains template strings. These template strings, they contain variables that can be instantiated by some tool. So for example, we can have like a robot template string like SC part of some %, which can be instantiated by robot and then be transformed in some OWL axiom like subclass of existential restriction, something like that. So the idea of a template is always you have a string, there are some variables in some way, and you have some tool that can take some data that will be materialized with the help of this pattern into some other form. So that's the idea of a template. And similarly, these in DOSDP YAML files, which we now tend to refer to as templates as well, which is the more appropriate term here, they contain statements like equivalent to subclass of all these like Manchester syntax strings that you have been editing, but also the template for how to generate a label where you say, for example, %trait, which is a template for a variable and the word trait coming afterwards. So what I want to say here is when we talk about, so DOSDP YAML files are best understood as templates rather than as patterns. We kept using the word patterns, and you will find this word patterns like littered everywhere, but a pattern is actually something more general. A pattern is a general modeling solution to a problem. So it's much more than what you would find in a DOSDP template YAML. For example, there are some assumptions about the semantics of the relationships you are using, and maybe there are other axioms that are important to take into account that we just kind of assume are present for this particular template to work. So we ideally now, among us, the 13 of us that are in this room, we should be starting to use the word templates when we talk about the YAML files. Template strings are the individual little things inside of a YAML file, like for example, the subclass of axiom or equivalent to axiom in a YAML file. We should generally avoid the word pattern unless we know what we're talking about. And when we talk about the table, then we maybe this is something that David has a different opinion on, but we should just refer to the table as the template table. So the DOSDP template table. This is the spreadsheet with the TSV information that we will use to generate the OWL. So it took a bit of time to go through these very important concepts, because we have been saying pattern for like a long time, but we really want to be talking about templates because that is what they are. They are not really patterns. All right, so preparation, I have already done the preparation, but when you follow this tutorial here, this assumes that you have created an ODK setup with this config file. We are going to create a cat anatomy ontology in some repo with some releases and some imports. So a very simple standard setup. We assume here you've done that already. So if you don't know how to do that, you can just refer to the introduction to ODK, how to set up an repo with ODK, and it will explain to you exactly. So I'll show you a bit how this looks like. Unfortunately, I cannot increase the font size of the menu on the left here. Can someone tell me whether you see my atom now?
Yeah, it is super tiny on the left.
Yeah, good. So what you see here, maybe I can also show it in Finder better. So with in Finder, so you see this is just a standard ODK setup, some release artifacts up top. There's nothing with DOSDP yet here. There's an ontology directory with your edit file, which is the one that you would open.
You sharing screen, Nico? Or? I don't see the screen share, or is it just me?
I think so. Maybe I need to reshare it because we joined late. Is this possible? Because everyone else seems to see it. Can you check, David, on if you are going on the menu? There should be some way that you can flip between the participants' screen. Maybe if you just open the participants menu and see whether my thing is there. Otherwise, I will stop sharing and reshare now. All right. David, if you have further problems to see me, just please let me know.
If you could reshare, that would be useful. Sorry. Thank you.
No worries. Now that's someone got wind of that we are building a cat ontology, I think.
Yeah, that's our cat.
Yeah. Okay, so can everyone see my screen now?
Not yet. At least for me.
Yeah, not yet. There you go.
Yeah, no, okay. So it's a standard ODK setup, as I said, edit file, nothing related to DOSDP patterns yet, just a super standard setup. So I'm not going to discuss any of that right now. That was part of a different tutorial. All right, so I will walk you through by referring to the documentation so that you can also repeat this easier when you're doing it in your own time. So the first thing we want to do is simply activating DOSDP in ODK. And the way that we do that, and that one thing that's cool about obo-academy is you can see that there's actually a copy clipboard button in any of these like gray code fields. So you can just click on copy here if you want to copy it. And what we need to do is we need to go to the cato, so that's my cat ontology odk.yaml file, which is located in the source ontology directory, and simply add this option to to the config file to just tell the ODK, look, ODK, please activate the DOSDP processing for us. There's nothing else you need to do. That's really the only option to get the default pipeline up and running. Remember, whenever we make a change to the configuration or whenever we update our ODK setup, what we want to do is we want to update also our we need to run an update command with the ODK. So it looks slightly different here for me than it usually looks because I need to use a different container because I'm doing lots of ODK development at the moment. But generally, it's just this, and you will see that also in the tutorial. It's just this run. So it's sh run.sh make update repo. So that command, what it does is it will execute the update process, and the update process really, so and that's why I want to show you this using my beloved GitHub desktop, which everyone knows that I'm not working with anyone anymore unless they install it. So you can see here, after running this command, so we have activated DOSDP equals true. You can see there are some changes to the make file. So the make file, as a reminder, is this place where our ontology workflows, like the release pipeline, the imports generation, anything is being orchestrated and captured. So all our workflows are encapsulated in the make file. So you can see there are a bunch of changes to the make file. Now you could look through them if this interests you. There's just a section being added on DOSDP patterns. A few other patterns are being extended. Sections are being extended, and so on. Also, we have a new directory, which is this like source patterns directory, which is so just under src source, which has a data subdirectory, and which in turn has a default subdirectory. This is where all our this is basically what we call the default DOSDP pipeline. This is where all our tables will go in the end. So this is, for example, if you have like a table, which we will create later, about different styles of hair codes for cats, then this table would go in this directory. Then you have this definitions.owl. This is kind of like the owl file in which all of the different owl statements that will be generated by our templates will be merged together. So you can have like multiple template tables with multiple patterns across multiple pipelines, but in the end, once all of these things are processed, all of them will go into the definitions.owl file, will be merged in there. Then there is this file external.txt. We will look at a bit how this works at the end. This allows us to share and reuse templates that are generated by other people. So for example, in the phenotype project, where we are making a lot of use of DOSDP, we can define all of our phenotype patterns in one repository, like the upheno repository, and then anyone like specific phenotype ontology, like the human phenotype ontology, can simply add links to these templates into external.txt, run a command, and then these will be imported into their local setup. And then there's this ontology called pattern.owl, which is a slightly controversial, but in David and my opinion, quite useful way to browse a set of patterns. So if you have like so what pattern.owl does is basically a kind of owl representation of all your patterns, assuming that the fillers that you specify. So when you say, for example, you have a filler like color pattern, which we will talk about in a second, like spotted or dotted or something. So color pattern for the hair code color pattern, so template, sorry, then here you would get the logical, you would assume that you have no data, but you will just materialize the template with its default fillers. And the advantage of this is, even if you didn't understand a single word of what I just said, because it was super chaotic, but the advantage is that you can just use this to just take a look at your patterns and see how they relate to each other, browse them in Protege, and just investigate them. So for us in Ufino, it's useful because we have like 400 patterns that go into a neat class hierarchy, and we can get some understanding of how patterns are linked to each other. Like, is one pattern a child of another? Sorry, one template a child of another. So yeah, I also still need to rethink these terminologies and so on. Okay, so very few changes. The key
Nico,
changes.
I have a quick question about what you just said. So how do you know a pattern, a template is a child of another one?
So for
based
example,
on what is inside, or do you define that?
No, so one example is if you have like a general pattern like abnormal morphology in that refers to the Pato class of morphology, and then you have another template which is abnormal size, and we know that remember in the DOSDP template we specify that the filler of the size is the Pato class for size. Then if you look in Pato, size will be a subclass of morphology. So if you just instantiate the template as with these filler classes, then the reasoner will understand that the one template will be more general than the other always, and will be subsumed underneath. So kind of that's the basic idea.
Yeah. We never specify a relationship. It just emerges from what you put into the patterns. But it gives you a nice browsable hierarchy of patterns if you've got a complex set.
Yeah,
okay, thank you.
Okay, so all of this is also described here in the tutorial, like what all these files mean, what they do, and so on. Okay, so we have done this now, so we've activated the pipeline. So let's just start adding a simple pattern. That's a simple template. All right, so we decide here to, it's a bit not like a crazy good example because no one would ever describe the poorest cat's fur in terms of the Pato color pattern hierarchy, but I do it anyways. So this here is a simple template. You can see it has a name, hair code color pattern. It has some kind of IRI. It has a description. And then you can see, okay, we have, we refer to two different classes. One is the color pattern class, which is this Pato class from the Pato ontology. Then the code of hair class, which is this class from the Uberon ontology. There's this relation, which is called has characteristic, which is a relationship from RO. And we declare that we have like a variable that is called color pattern. This has, just as an aside, absolutely nothing to do with this. You could rename the variable. Sorry, I should not use the word this with so much lag behind. So the name of the variable should not have nothing to do with the name, the ID of the class in the classes section here. It could be anything. So it's just coincidentally that they are the same here. And the variable, so we basically tell us, okay, we have a variable called color pattern. That variable refers to the color pattern class. That's the thing behind the colon. And then we actually have the rest of the part of the template, which provides us some very simple templates for generating first a label. So that's what happens in name. You can see % as code of hair with the color pattern variable. So let's just maybe take a quick look at the color pattern hierarchy so that you can all just see it. What happened with that color pattern? Maybe it's without the, and there you go. I don't know what happened with OLS, some problems with the deployment, but doesn't matter. Do you all see the OLS color pattern hierarchy now?
Yep.
Good.
Oh,
So
wait.
you can see here.
Yeah.
Okay. So you can see here, there's this is the Pato class we've used in this pattern. Underneath, in this template, underneath you can see colorless, discolored, multicolored, banded. I think I actually used the multicolored class, but doesn't matter. Blotchy, motley, netted, spotted, and so on. So none of this is ever used to describe cats, but in any case, we will do it. So yeah, so this so what this is basically then doing is, if you were to use, let's say, the spotted class from Pato in your template table, then this template section here would generate a label for your class, which is spotted coat of hair. I should have thought about this a bit, about the phrasing here, but it doesn't matter. Like that, that's what it's going to generate. The same, you have a definition which will generate a coat of hair with a variable, so spotted color pattern. And then we have an equivalence class axiom, which will generate an equivalence class statement, coat of hair, and has characteristic some. And again, the variable, again, the Pato color pattern variable.
Do you want to just want to make sure it's clear? So when the color pattern, so the vars, the second bit there after the colon is the range. So that's just saying that you must use either the term color pattern itself or some subclass of that term as your in that slot. So when you have a TSV, it has to be some type of color pattern you put in there, and it will give you an error if you use something else. I just wanted to make sure that was clear to everyone.
No, that's right. So this is what we should understand. These class declaration up top and the relation declaration is some kind of like range where we say when we use our variables, we then so exactly as
I guess I call those dictionaries. So that's just a lookup, because obviously if you were to write a pattern with lots of IDs in it instead, which we did going way back, they were really unusable and unreadable. Nobody could understand and share them, and people made mistakes a lot. So by having dictionaries at the top, we can give everything a name, and then we can refer to it by name in the rest of the pattern.
Yeah.
It makes it much more readable. But then that includes when we specify the range for a variable. So the range for a variable just says what can go in that column in the table when you populate it. So in this case, we've got vars take a range class. So it must be a class or subclass of the class or class expression you have in there. So it could even be something like, you could specify the range part of some head. And it could be anything that's part of a head. So it doesn't necessarily have to be a named class. But anyway, that's maybe getting a bit too.
I didn't even know that. That's cool. I didn't even know that.
That's why the weird quoting pattern.
Oh, okay, good. That makes sense. Cool. Yeah, we'll make sure that this will get introduced in one of the more advanced tutorial parts. That's really good to know.
Can I ask a question about the underscore?
Mm-hmm.
So do you need the underscore in, or can you? So for example, in a color pattern,
So for, I think that you do not need although that's for sure, you do not need the underscore for the class names up top here. But I think that I'm not even sure what would happen if you have.
I think you can get away without it in the vars, but I would not recommend it. I think good practice, anytime you have something that's a variable that's going to be used programmatically somewhere, just don't put a space in it, because it's going to break something somewhere. So I don't think you can get away with it sometimes, but I would strongly advise against it. Put an underscore there. But yeah, for the classes themselves, you don't need to put the underscore in.
I personally always put the underscores everywhere just because of habit, but I think that up here you can get away with not using the underscores.
But also if you use, it's okay. because for me it is simpler also, just put underscore then everywhere. So is that is okay, right?
Yeah, that's okay. That's what we would recommend. Yeah.
They're all internal. They're all of these. You could actually, you could call that Pato class Fred if you wanted. It would confuse everybody, but it wouldn't fail anything. There's no. They're all just, these names are all just internal to the pattern, basically.
I see. Okay.
All right. So let's go and continue with our quest. So we have now this. We want to create this YAML file. So I will go into the into my directory, into patterns, DOSDP patterns. Then I will create a new file, which is what was it? Hair code color pattern. Hair code color pattern dot YAML. Paste this content. So I created this file now inside of my directory. That's great. Now the next step is to actually create a data table that corresponds to this pattern. So this template. So we have a simple. I just have a simple example here, which is a table that consists just of 2 columns. That's the minimum we need to use this template here, which is the defined class column. So the defined class column contains basically the ID of the terms that we are seeking to create with this template file. And then we have the column for the variable which we specified. So in this case, we only have one vars, which is color pattern. That is this one. So that is kind of like for everyone to keep in mind. The absolute minimum is that you have a defined class column and 1 column for each vars. That is must. It cannot work without that. But then there are like many other things that's outside of this tutorial now that you can also add there to override the labels and add other things to the definition here. But we don't really care about this in this tutorial. So that is just the minimum we need right now.
Nico, a quick question. You just said the class we want to create. So just to make sure for myself, we are creating new terms. It cannot be something that already exists. Is that right?
No, it's actually a very good question. It can absolutely be things that already exist. So let me just finish this one moment here. Sorry, I don't see the special signs here for some reason. Just trying to find any file that contains a tab that I can just quickly copy. Nothing. Anyways, I'm just trying to do this manually real quick. So this is basically somehow my my editor stopped showing me because I named it wrongly. That's why. So TSV, that's better. Okay.
Go to view and choose show all tabs. That should work.
That's it. No, that's not. No, that's not the right one.
Oh, that's a different kind of tab. Sorry.
No, that is. But the thing is that that this always this just never didn't show it to me. So let me just copy it from an existing one. Doesn't matter. Okay, I'll just take it from here. There you go. That's one. All right, sorry about that. Now back to business. So I saw now that's something I need to fix in the tutorial, that when you just copy it, they seem to not have tabs in it, which is odd. But in any case, so this is the minimum table, as I said before. And with Sabrina's question was about whether we can use these templates here to override other, to add information to terms that already exist. The answer is yes. And we will also look at this in like 4 minutes concretely. So just for now, that's the last step I wanted to show you, is how do you run this? Generally, there are some kind of like, for running releases, you know, all these pipelines in ODK that will generate and do all of these things fully automatically. But for the sake of this tutorial, I decided to show how these are done in a more step-by-step way. So so what we will do now is we will create the definitions.owl file based on this table that we put in the default folder of the data directory, in the patterns directory, and the DOSDP template that we just created before. So I'm just running this now.
How much of that automatically runs now in ODK? I know you've kind of gone back and forth a little bit.
That's all running completely automatically. Like whenever any goal that, for example, you have when you're preparing a release, let's say, any goal that needs that creates a release artifact will depend on definitions.owl. So definitions.owl is always.
Yeah, I just wondered, does it happen in the pull request or?
No. There's nothing in the pull request. So that's kind of like a thing that we need to decide between. Also, how we have not done any of these things with the pull request automatically. It adds generates a file and attaches it to the pull request. We've done none of that in any way, not for this and not for any other process so far. But yeah, it would be.
But it will run a check. Well.
Yeah,
right,
so
I guess so. I should let you get on, but I'm wondering what checking it runs then on the pull request. So I presume there's a lot of checking in case you've made a mistake in the pattern files, for example, or presumably those will happen.
So these are all running at all times, but so the pattern checks directly. We have some new things that are coming in the next ODK version that will do some validation over the tables, but like minimum, like more structural validation. But if you wanted to really like run the entire pipeline to be 100% sure that everything is correct, you would have to extend the test goal where we explicitly exclude the full generation of all the patterns in definitions.owl right now because of runtime restriction reasons. So this is something that you need to set actively if you want the whole pipeline to run. We can revise this decision eventually if you want, but right now that's what it is. All right, so we can see from this little table that we've created. I'm just opening this definitions.owl for one moment in Atom or in my text editor, so just so that you can see what actually happens. So it's created a nice complete OWL ontology, which contains all of the typical OWL axioms and OWL annotation assertions in it. So, for example, it has this this annotation assertion in here, which is from an IO 10115 definition. So this is our definition property for this Kato1 class, a coat of hair with HTTP : blah 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 Pato 333 color pattern. So we look at this and we're like, okay, this is really this is not what I wanted. Obviously, what you wanted is that this says here spotted color pattern and not HTTP something something something. So I created a big explanation about exactly why that is when you are first running the pipeline. in this tutorial. So I really invite you all, if you're working with DOSDP pattern, to really carefully follow all of these explanations that I add in here. But for this tutorial here, because we're already quite late, long story cut short, DOSDP tools, in order to be able, so DOSDP tools is the tool that takes the YAML pattern, the YAML template and the template table, and processes them together to generate OWL from it. And in order for it to do its job, it needs to know about what Pato 000333 actually is. It doesn't know that by default. So we need to tell DOSDP tools this information. And the way that ODK tells this information is by telling it, just look in the ontology. And so right now, this Pato class is not in the ontology. So what we need to do, most of you will have done that at some point in the past, is actually refreshing the import that has this respective terminate. So I'm running the refresh command. The ODK again knows exactly what terms it needs to import, so you don't need to tell it import 000333. It will see from the fact that you have been using it in definitions.owl that it needs to import this term. It's dependent on this term, and it will automatically know that it will have to import this term for us. So I will let this run now in the background. One thing for those that don't start out with a DOSDP setup, but actually add the DOSDP setup later in the evolution of your ontology. So you need to add the DOSDP imports the exact same way as you usually add the normal import. So remember, we've discussed it once in the past. How do you add an import to an ontology in the ODK way? You do exactly the same thing here now. In this case, I've already done it because I didn't want to waste time, but the tutorial explains it. You need to add the redirect to the catalog file. I will do that as well in my little ontology now. And the second thing that all of you that will have done this in the past remember is you also need to add the import statement to the edit file if you want to see these the templates, the OWL of the template in Protege when you open the edit file. All right, ODK doesn't care about this. It knows, and it will deal with it anyways. So now it has refreshed the import. Now it knows about the term, but it still didn't regenerate definitions.owl. So we are just going to run the definitions.owl command again to now telling DOSDP tools exactly the labels that it needs to generate the information. And we see now in I closed it. Definitions.owl that now the coat of hair with a spotted color pattern. So perfect. It did it well. So everything is fine now, and it was all created correctly. So now let's just take a quick look at the edit file. So and remember, yeah, just interrupt me if something is too fast or something. Just want to show you real quick what we just did. Spotted coat of hair. So inside of Protege, you can see now we have created this nice class. It has this label, spotted coat of hair, has this IRI, Kato1, has a definition, a coat of hair with a spotted color pattern, and it has an equivalence class axiom, Uberon 0010166, and has characteristics some spotted. Obviously, this is very early, very much work in progress. What would you do next here when you see this? So obviously, we also need to refresh our Uberon import for if we want the definition to have all the logical axioms that it needs, but this is not relevant as part of the tutorial. The point that this is making, that I just want to make here is when you are dealing with this DOSDP pattern workflow, you should, when you're debugging things, you should always think about DOSDP tools needs to know the terms before it can generate the labels and the kind of information correctly. And in order for it to know it, these terms need to be present in the ontology or in the imports of the ontology. So that's kind of like a very piece of information that I explain in very much detail here in this tutorial. Great. We are moving now to a small separate thing. So I want to show you how to use external.txt. So we've been using this a lot in Ufino, as I said earlier. So this is just a way for us to reuse templates that have been defined elsewhere. And you simply add a URL to this external.txt file, and then you go and just run the update patterns command here, and this will download the file. And you can see now in your Git client very nicely that I have just imported from OBA, so from the trait ontology. I have imported the entity attribute pattern just to illustrate what's happening here. And you can see, okay, good, I have this pattern now, this template now. And next time, let's say the OBA developers update this template and add something to it, and you run the pipeline, it will also update your pipeline and will make sure that your entity attribute YAML file is also kept up to date with whatever stuff you have in this external.txt file where you just added the URL. So that's kind of like just an important mechanism for sharing templates across different DOSDP setups. All right, so now let's do the last thing, which is like managing multiple pipelines. This will also answer your question, Sabrina, with whether we can use DOSDP also for or just augmenting existing terms. So I'm going to copy this snippet here. I'll explain it for a moment. So this is the pattern pipelines group snippet that you add again to your ODK config file. Okay, let's look at this a little bit. So we have this pattern pipelines group section. Underneath, we have the product section, and in the product section, we have two different list items. One is has the ID manual, one has the ID auto. What will happen now is that the DOSDP tools pipeline will generate two parallel pipelines, one that is called manual, one that is called auto, that are configured with different DOSDP tools options. So one thing, and I explained this also in the tutorial quite a lot, like one reason why you might want to have multiple pipelines is, for example, if you have like a project in which some of your DOSDP terms are automatically generated by some process, which is a lot the case, for example, in Ufino, where you have where you auto-generate these template tables from some data science, from data engineering pipeline, and others that are manually curated by humans. You don't want to mix those two. You want to keep them in separate directories. So what you do is you specify separate pipelines. And in particular, you also need this if you want to say, okay, for this pipeline here, for the manual pipeline, I actually only want to generate the logical axioms, not the labels, not the definitions, not anything else. And the rest of the stuff I want to do in Protege. So that pertains to your question, Sabrina, that you can curate your hierarchy like you do in Mondo using Protege, and then you add this, you can just tell DOSDP, I want to do all my curation in Protege as I was. Please only generate the logical axioms that are defined as part of the template file. For example, the equivalence class axioms or the subclass of axioms. Okay, let's just update the repo real quick to see how this will look like. So in your directory, you will see now in the data directory, you will see now another data directory, which is called auto, which is the name of this pipeline here. It's irrelevant what you name it. You can name it whatever you want. Like we have in Mondo, we have like a pipeline that is called matches, in which we manage automatically matched DOSDP patterns, for example. But it just doesn't matter what you call them. You can call them anything. And you can see that setting this will create separate directories in your data directory. You have the old default directory, you have now the manual one, and you have the auto one. And it will also have extended the make file in a way that now the ODK knows that it will take into account anything that is in the auto, in the manual, and in the default pipeline when generating definitions.out. So all of this stuff will be generated, one by one, and then merged together into the file, which is called definitions.out. Okay, so that was a lot of stuff.
I'm wondering whether, Nico, it's worth emphasizing there, because this was, I think, Megan's question yesterday as well. So that when you have a DOSDP table and that you reference an existing term, you're always just adding to the content. So there's never any overwriting. So if there's a label, I mean, this is just basic way that OWL works, I guess, but there's never any case where you're stripping out a label and replacing it with something. You'll just be adding an extra label or adding an extra whatever's in that pattern. Does that make sense to everyone? Just to be clear. So if you really had some stuff that if you were managing, like an equivalent class axiom on a term in the originally in your editor's file, then this would just add an extra equivalence class axiom. You'd have to go through and delete the existing one. I don't know if, Nico, there's any way to manage that more gracefully, but
so I think it is actually quite good, but we can discuss how to improve it a bit. But that's a very good thing that you just said, just to illustrate this with OBA as well. So if you open the OBA edit file, you will see that there are like a bunch of axioms in the OBA edit file, like some subsumptions, so subclass of axioms. There's even some names, which I'm not sure they should be there. So that's just a fluke here. But in general, you could put anything you want into the edit file. The DOSDP pipeline itself will not kill anything that is in the edit file. It will just add to it. It will never delete anything from here. So whatever you see in here will also appear in the final version of the final release version of OBA as well. All right, any other questions about this?
I have a quick question. So I remember at the very beginning you were like saying how the term would read. You're like, oh, I should have thought about that. But I've run into issues where like most terms sound normal, and then there'll be like a term that sounds really weird. How do you fix that? Do you just go edit after it? But then if you kept updating your ontology, I would assume it would revert back to the pattern, not to what you've made it sound better as.
So you mean, okay, so are you talking about editing the spreadsheets right now, or are you talking in general? So I think maybe just, can you just restate that for a question, or because I'm not sure.
If you go back to the tutorial page, I remember there was, and you go to the pattern, there's something where like coat spotted coat didn't make sense or something. Or like spotted coat of hair. right?
Yeah, exactly. That's bad. Yeah.
Right,
So
right.
you would yeah. Go ahead.
So how would you fix that to make it sound nicer? Because maybe most patterns work with var coat of hair, but that one doesn't.
Okay, so that's a very good question. Let's answer this again with OBA, because I haven't set this up now in this little tutorial that I just provided. But the way that this works is we work with overrides, and overrides are basically special columns in our DOSDP data tables that allow us to say, if DOSDP tools, if you see something in that column, always prefer whatever you see in that column over whatever it's overriding. So for example, you see here in attribute location in this table, you see there is a column define class underscore name. If DOSDP sees a value in here, then it will always prefer that value over the value that is generated in automatically with the template file. If, like, let's find a better example here. So this is a good one. So this is the chemical role attribute template table. So you can see there are two classes up here whose labels are overwritten, and then there are 4 classes underneath whose labels are auto-generated. So there's no value in this column. So these are all generated automatically by the table. So whenever you have a case, spotted coat of hair doesn't sound nice, so you want just spotted hair or something, or spotted hair coat, you would go and define an override column in your table and then add this label to the override column.
Okay, and in the table, does that have to also be specified in the pattern itself, or is that just in your TSV?
It's just in the TSV. There's
Okay.
nothing that is these override columns. They don't appear in any way in the template files. They only appear in the
Okay.
tables.
Okay, that's good to know. Thank you.
Any other questions? I know that a lot of this is a lot, so we need to know basically. So for the next round on DOSDP, I think next time we will intersect and put a lesson, an advanced lesson or medium advanced lesson on Sparkle. But for the next DOSDP focused lesson, I think we need feedback from you, and don't worry about, even if you want to go back to the basics and just talk about David has started creating a nice additional tutorial here, and if you just want to start talking about how do we actually build good YAML files, and if that's what you really are interested in, just let us know, because from our perspective, we do this just for you, so we care only to teach the things that you want to know. So just let us know what parts you want to get more details about. I would suggest, and please correct me and contradict me, though, that next time we do a Sparkle session, just to mix it up a little bit, and then we can go back to DOSDP another time whenever, either the time afterwards or whenever you are requesting it. So remember, this is just for you. So does anyone have anything against this, or do you prefer to do another week of DOSDP and go in some details somewhere else? What do you prefer? So is no one against it? Is anyone, can at least 2 people verbally confirm that it's a good idea to have a Sparkle session next time?
Yes.
That would work for me.
Yes.
Yeah, that'd be great. Thanks.
Yes.
That's great. Okay, good. Time's up. Thank you very much for coming, and and see you next time, and have a great week.
Thank you.
Thanks, Nico.
Thank you.